Okay, guys, let's quickly look through these two. We might add one or two questions on acid and base. We'll see as we go on. But let's quickly look through our electrochemistry. Very, very important. And we're looking at 25 marks there. And the main idea here is to please remember how to, number one, so just a quick checklist, electrochemistry. Number one, what definitions are we expecting? We are expecting oxidation times 2, reduction. When I say times 2, I hope you understand what I mean. One in terms of electron and the other one in terms of oxidation what? Numbers. Just giving you a quick checklist that I can remember. What other definition should we be looking at? Agents. Oxidizing agent and reducing agent also times 2. And knowing what is oxidized and what is not oxidized. Number 2, identification of your what? Anode. For me, point number 2 is electrochemistry. If you miss that, you have missed the whole thing. And I think I gave you 10, if I remember. 10 ways of identifying your anode and your cathode. Very, very crucial. Maybe I'll run through it again because it's important. Once you miss number 2, you forget. Number 3, I'll run through it, but quickly. A checklist. So do I know that? Number 3, half reactions. Half reactions. And what table are we using? 4B, the easiest way. Okay? Half reactions. And this is connected to what? Net ionic equation. You see, I'm not even talking about the cells yet. I'm not talking about the cells. Then number 5, we can now look at the cells. And if we look at the cells, what cells do we have? Cells. And we need to look at energy conversion. We need to look at the operation and application. So if we can remember all of this, we would be fine. Energy conversion in what type of cells do we have again? Electrolytic and galvanic cells. So for me, this is a beautiful checklist, and definitely, definitely Stoichio. So let's add number 6 to it. I know you took a picture, but stoichiometry. So we're looking at 25 marks, as a whole. So can we, for 15 minutes or so, just touch on all of these points? Then we can jump into, once you understand it, we won't take time on questions. But if we don't understand this, we will spend a lot of time. So please, let's go through some of these things as quickly as possible. All right, so definitions, can we not waste time? And that I hope you got all your definitions correct in this paper. Don't start with me. Don't even start with me. And chemistry is worse. Chemistry has, I think I counted, no formulas to guide you here. Chemistry has 75 definitions. Organic chemistry has half of it, 36. I was very meticulous and I counted. It has about 75. Organic alone has about 36 out of the 75, which is exactly 50, almost 50%. Okay. All right, quickly, let's run through. So some of these definitions, I'm just going to say them. I won't write them. Let me ask you, please, can you answer number 1? Define oxidation. Just write them down quickly. It won't take us time. I have 6 definitions here. Define oxidation in terms of electron transfer. Define reduction in terms of electron transfer. define oxidation in terms of oxidation number, define reduction in terms of oxidation number, and define oxidizing agent and reducing agent. Let's tackle number 1 very quickly. I'll give you 3 minutes. There's just 6 definitions. Write what you can remember. That's how we're going to remember, to say, okay, I missed this, and these are the words that I missed. 3 minutes, 30 seconds. Come, let's do it. 6 definitions: oxidation and reduction in terms of electron and oxidation number. Then you define oxidizing agent and reducing agent. Are we done? Shamil, are we done with those definitions? I want to see all the 6. Can I mark? Do you have all the 6? I don't want to mark it in your head. I want to mark black and white. No, please write the correctly, because O I can say is orange and R is red grapes. Please, I want you to give me the way it is in the exam. Don't start with me today. It's a Friday, please. It's Juma today. I don't want to fight. Please. Like you got everything wrong. Everything wrong. Please pass yours. Pass that young man's. Guys, okay. Those of you online, in case you hear, please know that things are happening here. I'm going to move people here. You're playing with me. You are playing with me.
Did you say right what I remember? That's what I remember.
That's what you remember. Okay, I'll give you just 2 out of 6.
Okay, I'll take it.
2 out of 6. Letabo? You only got 2 definitions. Matter why, people? Matter why? Why? Okay, we're going to run as quickly as possible. And here is my little cheat. Here is my little cheat. Thank you very much. And you have those definitions. Let's see, 2024. Any paper? But I want something national. Let me see 2022. There's something I'm looking for. Okay, so guys, quickly, almost all of these definitions I asked you are all here on your formula page. All right, so they are here. on your formula page. If I quickly get them, I won't write them, but I want you to listen carefully and check how I would use this to define. Let's cut out the Afrikaans, okay, in case somebody is speaking Afrikaans, and yeah, and somebody gets to see this. Okay, look at this. All I need to do, you know what I'm doing right already? I'm going to draw an arrow downwards. And I know that when I see a negative, I'm going to call it a loss. And there's a plus here. It's a gain. So there's a plus here, which is a gain. This minus is a loss. There's a plus here, which is a gain. And this minus is a loss. Okay, so what do we do? What is, by the way, what's the symbol for electrons? E. So we're going to take this E as my electron. So check, what is reduction? I'm going to come here and say reduction is the what? There's a plus there, gain of electrons. So reduction is the gain of electrons, while what? Oxidation is a loss, because there's a minus in front of it. What is an oxidizing agent? An oxidizing agent is a substance that does what? Gains electron. What is a reducing agent? A reducing agent is a substance that does what? Loses electron. I've done 4 out of 6. What's the remaining one? Oxidation number and what? Reduction. Oxidation and reduction. In terms of oxidation, what? Now, if I say reduction, it's a reduce. And a reduce is a decrease. So what is oxidation? Oxidation is what? An increase in oxidation number. Increase in oxidation numbers. That's the key, numbers. While reduction is what? A decrease. Okay, so your 6 definitions done. 4 from the formula page, and 2 you must just need to swat it. And I think that's what they would ask you for now. If I remember any other thing, I would let you know. So number 1 is done. Quickly. Number 1 is done. Just throw your arrows down and get what you need to get. What was our number 2 point? Identification of what? The anode and the cathode. Okay. I want you to just pop whatever you remember for me. We're going to make a list of about 10. Those of you at home, please go ahead as well and let me know what you remember. Anode and cathode. Yes, number 1. Yeah? Anode. Oxidation occurs at the anode. And also we can get that from that formula. If you go back to the formula, you would see anode. What happens there? Oxidation. And what do you find there? You find a reducing what? Because the reducing agent is oxidized. So they can play around with all of these things. Just use your formula page to guide. Alright, so yes, hold on. Cathode is where reduction what? Occurs. Okay, I think I heard a pimp there. Somebody wants to give me something. Number 2, who's giving me something? Oh, the anode is where we lose what? Oh, people are now pouring in stuff. Anode is where we lose electrons because oxidation is lost. So we talk about transfer. The loss of electron and the what? Gain. Which means loss of electrons. Which means electrons would move from where? Anode to cathode. Movement of electrons. I figure out them out. They'll use that on Monday. Watch that. Figure they'll use that. Yes, talk to me. All right, Jessica is giving me one here. Ape. Talking about polarity quickly. I'm just going to list it the way you're giving to me. Ape. So we talk about polarity. Ape. What is the full meaning of ape? The anode is positive. In which cell? Electrolytic cell. What does that tell us? It means the anode is therefore what? The cathode is negative. Cathode is negative. In which cell? Electrolytic. Hold on. There's something connected to this one immediately. No, hold on. Can we switch it quickly? Can we move to the galvanic, because we're mentioning cells now. So what happens here? The anode is now what? Negative. It switches. In which cell? In the galvanic. Here, the cathode is now what? Positive. But all of this, we're picking from the acronym what? APE. So APE informs us on two of them. You were talking about something there? Okay, what about them? Homophones. Anions will always go to the anode. Anions move to the anode. And then what? Cations move to the what? Cathode. Even through your salt bridge, that's the same thing that will happen. Anions. By the way, can we talk about the signs? Anions are what? Stop lying. Negative. Cations, don't forget. C-A-T. That T is a plus. So positive. So don't forget, even in both in the electrolyte and the salt bridge, whether electrolytic or galvanic, the anions will always move to the anode. NN and cat. Give me more. Number 6. What do you remember? Guys, someone is gaining electrons. What happens? If you are gaining, we said gain of electrons. What happens when you gain? Come on, if I'm gaining, someone say, oh, Bishop, you're gaining. Increase in size. Come on, I'm gaining. So the cathode will what? Increase in size. While the anode will what? Decrease in size. Good, you're talking now. Anything I want to electroplate goes to the cathode because it must increase in size. Number 7, material to be electroplated. Material to be what? Electroplated. And what do we have here? Material we are electroplating with. Material used for electroplating. Give me more. This is the core of, if this table is the core, you miss this one, you miss net reaction, you miss cell salt, you miss everything. Come, I need more. There's more. Give me the E values. What about the E values? Those values on the right hand side, we'll talk about electrode potential values. There's something we said about that. Yes, talk to me. Who remembers? Yes, sir. Talk to me. Okay, Jessica, I'm coming back to you. More negative is the anode, your number line. Oh, yeah. It is A, N, C. So my number line is from negative to what? Positive. So number 8. Number 8. So look, we want to catch the examiner. We want to block everywhere. They are going to ask us electrode potential. Electrode what? Potential. We use a number line. My number line is like this. And we know it's from what? Negative to positive. Anode and cathode. So the more negative will go to the anode. The more positive value would go to the cathode. So here we say more negative. Can I just do this? And then here, more what? I didn't say positive. I said more positive, because it can be negative, yet more positive. Okay, come. There's more, I think. There's more. No. There's more. Tell me about the table. Tell me about your 4B table. No. Tell me about the table. Your 4B. How do you use your 4B table?
Zuma.
Yes. Okay, Zuma, lovely. Ex-president. Tell me about him.
On top.
Good. It's ANC. So on the 4B table, what do we have? The first one we see. So we write Zuma, right? Jacob Zuma. That's our beloved chemistry teacher. But what do we know? It's still A and what? C. The first one is the anode, which means that is where oxidation takes place. And this one is reduction. And this one would inform you on how you write. All right? Come, there's... Okay, let me probe you. There's still one more. I think there's one more. No, that one we just want to identify the anode and cathode. There's one more. Under electrorefining. There's one more. Yes, number 10, electrorefining. Where does the pure one go to, and where's the impure one go to?
Oh, the pure one goes to the cathode.
The pure one goes to the cathode because I want to cover it with more pure. So electrorefining. At the anode we have what? Impure metal. And here we have what? The pure metal. Please try to sit with this thing. Know the 10. I think we covered. Good. The anode before the cathode. A before C. So guys, please know this. If you know this 10, I think you are sharp. You are. There's nowhere they want to attack you. You are, because we've mentioned salt bridge already. Using the anions. We've mentioned polarity. That you can use plus or minus on the galvanometers. All right? Yeah. By the way, okay, we'll talk about that in the cell. So this is my point number 2.
The anode is negative in the galvanic. Yeah? But it doesn't really play a part.
It does.
Does it change it?
It does. Remember that your ions are now attracted to those electrodes. Because we talk about 3 processes there. No, it goes towards the cathode. That's polarity has changed. Okay, don't worry. We're going to get there now. Oh, let's have you writing. Okay, which point are you? How far are you? Okay, while she's writing, somebody just take a picture of this and drop it. Okay. Who's taking a picture? There are 2 groups here. Drop it like it's hot. Drop it like it's hot. Drop it like it's hot. Just drop it. Eh? Yeah. Next page. I came back around 1. And at 4, I was already sending answers.
Yeah, I was away from 4.
Okay, so do we have a picture of this now? Please, let's check. Mohammed, do we have the 2 pictures? Oh, great. Oh, beautiful. So many people sending. Lovely. Thank you very much. Okay, what's our next point? Our next summary quickly. Half reactions. We covered that, right? Anode and cathode. Half reactions. Cell notation. Okay, we'll talk about that under cell. Okay, let's look at cells quickly. How many cells do we have? We have 2 cells. Electrolytic and what? All right, quickly. Guys, tell me everything you know about electrolytic cell. Quickly, start. Electrolytic cell. Wait, say it again. What's the name of the cell? Stop. That's what I want to challenge you. What's the first word you say when you say electrolytic? Elect. So electrical energy to chemical energy. So don't forget that. Electrical, because it's electrolytic. Electrical energy to what? Chemical. Okay, talk to me. More.
Are we using the platinum finger?
Okay, not yet. Not yet. It's non-spontaneous. It is endothermic. Yes. Because we are now providing an external power supply. What type of power supply? Stop lying. DC. Why DC?
Oh, so it doesn't switch the polarity?
Yes. To maintain electrical what? Polarity.
How much is the salt bridge?
No. Salt bridge is not here.
Must we get the 25 degrees?
Not here. All of that is a galvanic cell. Okay, what else? What else here? What else? What else? Give me the processes. Where do we use all of this? Oh no. What is? Oh wait. Definition. 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 Number one. What is electrolysis? Number two. Electrolyte. What is electrolysis? It's a process. Okay, I'll help you. But know that it's a what? What is your energy conversion? You are done with that definition. It's a process of converting electrical energy to... It's all about tricks here and there. So it's a process, then you go back to the function of the cell. All right? It's a process of converting what? The problem is you don't want to sing my songs. Converting electrical energy. Let me start posting those songs. I need some views. Yeah. I've forgotten the lyrics. We use electrical energy to create a chemical change. This is electrolysis. That's under definition. We use electrical energy to create a chemical change. Electrical energy to what? Chemical energy. That song must go viral this weekend. What are electrolytes? Electrolyte is an ionic solution. Guys, can we just listen to songs? I'm going to bring some speakers now. Guys, just go listen to those songs. The definitions are there. Let's show people where to get the songs from. Let's do some quick marketing. The songs need to go viral. Want to become the new Mary J. Blige? No, Mary J. Blige is a woman. What should I say? Crazy physics. Please just go listen. I promise you, all of these definitions that I'm shouting, they are all there. What should I look for? Redox. Crazy physics redox. Let's see. I think it should come in here. Oh, this is grade 11. All right, there we go. The side to side talks about the general, but I'm talking about electrolytic cell. We should find it somewhere. People are using my name as their hashtag. That's why I can't find my stuff easily. No, let's say crazy physics electrolytic cell. Let's be specific. I need to go change all of my hashtags. Crazy physics electrolysis. There we go. I'm just going to play it quickly. Those of you there, I'll just sing along. It's a nice rhythm. Yes, if you can see me right now, I'm moving on the tables. I wanted to see the definitions. All right, I know you might not be able to hear, but maybe you can. Look at the words. All right, We use electrical energy to create a chemical change. Definition number 1 is done. This is electrolysis. Now, second, electrolyte is an ionic solution that conducts electricity through the movement. I am done with that definition, right? Now, the process to an electrolyte, to break down the electrolyte in 3 stages. 1, the electrolyte into cations. So step 1, we break down into cations and anions. Number 2, move towards the cations to the cathode, the anions to the anode. The anode is positive in this. You see, every statement carries a meaning. Oh, can you hear my voice there? Yeah, it's a lie, I'm not the one. Step 3, oxidation at the anode, reduction at the cathode. The ions are reduced to solid. The cathode becomes bigger, it gains weight. Electrolysis. Now, what are the processes? Electrorefining.
Deposition of copper chloride, extraction of aluminium, chloride, alkali industry. Yeah.
Done. So easy. Not you. Don't want to watch other people's stuff.
Meat base 44.
Okay, but please, what am I doing? Let's move away from here. No. Okay. So please, guys, you would notice everything I wanted to mention here been talked about. Just learn the lyrics of the song. The process is already done. When we get into questions now, we'll look at a few of the processes. Okay. But this is the one that has electrochemistry in it. Can we quickly look at the connection of electrochemistry? Quickly. The stoichiometry of this. If you remember, there's one big formula that we came across. When the examiner says calculate current. What is current? I equals to what? Q over what? Delta T. What is Q? We go to electrostatics now. So what is Q? N QE. What is this N? It's the number of what? Electrons. What is this? The charge on an electron. But how do we get this N? We go to Avogadro's, where N, now this is what the problem is. N equals to N over Na. If you look at my arrow, do you notice my arrow is not going to the small n? This capital N is the number of what? Electrons. This is what? Avogadro's constant. And what is this small n? The number of what? Moles of electrons. So watch how the n changes. So for clarity, let's do this. Let's make this a capital N. And that is your stoichiometry. Then you remember your 3 steps of stoichiometry. They will not give you what you are looking for. Step 1, step 2, step 3. All right. When we look at questions, we will be able to answer. You cannot see my screen. Can you guys see my screen now? Oh, maybe when I went on YouTube. But I will reshare those songs. Reshare the link. Please share it with your friends, enemies, those who are not doing science, those who are doing accounting. They must just listen. Let's up the views. I'm going to reshare them on TikTok again. Okay. I'm not even making money from them yet. But let's just help people. All right. Can we go to galvanic cell quickly? Galvanic cell. Galvanic cell. You want to tell me what you know? Number one, energy conversion.
Chemical energy into electrical.
Good. So here, think of a battery. So we're talking about what? Chemical energy to what? Electrical energy. You want to keep talking? Keep talking. It is a spontaneous cell. So it is what? Exothermic. That's why your battery is always warm. The reaction occurs on its own. We need to look at that word spontaneous again. What else can you tell me? Good. Standard conditions. What are my standard conditions? Okay, we talk about temperature of what? 25 degrees Celsius or 298 Kelvin. Next. Pressure, 1 atmosphere. Next.
1 mole.
Concentration, 1 mole per cubic what? Decimeter. What else can you tell me quickly? It has a salt bridge. Can you quickly tell me about the salt bridge? Function. Okay, let's start from it contains high concentration of inert solution. High concentration. Is my concentration correct?
No.
I could feel it. High concentration. Is it C or S? C. Okay, high concentration of what? Inert ionic what? Solution. Now, what are the uses or function? Yes, number one, there are 2 of them.
Maintains electrical neutrality.
Beautiful. Maintains what? Electrical neutrality of the half cells. But how? How? Let's add to this. How? Not transfer of electrons, transfer of ions. Lovely. Allowing transfer of ions. But how? Let's be specific. How are the ions moving? We just spoke about that. Anions will move to the anode, and cations will move to the what? Cathode. Okay. Second function, it completes the circuit. Beautiful. Okay. What else can we talk about here? Number 6, the use of platinum. I want you to tell me when.
Use it when you use the gas.
I want you to tell me when and why.
Because it is enough.
Okay? So are you giving me when or why? Why? Okay. Why do we use platinum?
It is inert.
It is inert.
Conductor.
It's a conductor. And it's a solid. I'll send the song that has all of this one as well. It's called Side to Side. That's all of this. When do we use platinum? When we have a gas. Mixture of ions. For example, if I have ion 2 and ion 3. Next one, non-conducting substance like iodine. I don't know how I remember all of this. Non-conducting what? Substances, e.g. iodine. Okay. Are we good so far? Just a quick summary, just a quick rundown. What else can you tell me? Contamination. Okay? All right. I'm going to catch you on that one now. On that silver nitrate you're mentioning. But so far so good. Look, you know all of these things. We're just quickly drawing them down. And these are your checkpoints that you need to know. Before we go to that, okay, under contamination, what principle are we going to use here? Point number 7. Please, can somebody tell me what a flat cell is? Good. We are saying the reaction is now at the state of what? Reaction is at a state of chemical equilibrium. And what is the value of the EMF? 0 volts. 0 volts. Number 8. What are the factors that can affect my EMF? Factors that affect EMF. They are simply factors that affect Le Chatelier's principle. We talk about what? Concentration, pressure, and temperature. So we are simply looking at what? Le Chatelier's principle. So we'll understand Le Chatelier's principle again. Last point on this, I want us to jump into questions. Oh, before we jump into questions, how do we write our salt bridge? Okay, it must start with, okay, before we go to that part, what's the arrangement? It's as simple as ABC. A stands for the anode side, B stands for the salt bridge, and C stands for the cathode. But it must start with what? A solid, and it must end with what? A solid. What do we call these strokes? Phase change or phase separator. When we separate phases, solid and liquid, we talk about a phase what? Separator. Okay. That's where platinum comes in. Don't forget, platinum would come in there and be a solid. That is the mixture of ions that we spoke about. Okay, guys, I think I'm tired of talking. Let's see. Whatever thing we don't remember, we'll answer it when we deal with the question. Will that be fair? Lovely. Lovely, lovely, lovely. Okay. Guys, let's start with something very soft. Something very soft. Please get your tables out. So we keep the question. All right. I think this is a lovely one. Oh, I love this one. Beautiful. Spontaneity here. 8.1. So get your tables out, run, get a question paper. Wow, that was a detailed summary. I promise you. That was a very, very detailed summary. I'm giving you 5 minutes on this. What do you remember? A piece of zinc is placed in a test tube containing an acidified permanganate solution. After some time, it is found that a redox reaction has taken place. Use the table to answer the following. Write down the name or formula of the reducing what? Agent. So we're basically looking for zinc and that. So from your table 4B, which one is on top? Zinc is on top. So zinc would be what? Oxidized. So if you check your table, you have zinc on top and you have what? Permanganate ion at the bottom. So this is anode and this is what? Oxidized. And I think we are done. Whatever is oxidized is your reducing what? Agent. So 8.1.1 is zinc. Refer to the relative strength of oxidizing agents to explain why a redox reaction will take place. So we are looking at oxidizing agent. Which one is a stronger oxidizing agent? MnO4, permanganate ions.
Oh, yeah.
Because it is reduced, remember? We don't even, once you use the table, you are done. So we're saying MnO4 that is a what? Stronger oxidizing agent than what? Zinc. Therefore, MnO4 minus will be what? Reduced. 3 marks. 1, 2, and 3. Because we see, 3 marks. Just like that, Papi. 3 marks. Identify, you compare, and then you write a conclusion. 3 marks like that. Guys, are we okay with those 3 marks? Response quickly. Are we okay with those 3 marks? Don't write stories. Don't write stories. It's 2 statements and you are done. Okay. Oh yeah. Let's answer this question. Okay, guys, this one is, we should do this one very fast. Just want to give you 6 minutes or so. Use the table. Quickly. 1, 2, 3, 4, 5, 6. Not more than that. Let's go. Okay, guys, let's mark this quickly as possible. We don't want to waste time on this. Write down, I think we answered 8.2.1 already.
Yeah.
Write down the function of component Y. We gave you 2. We mentioned 2. What is component Y in itself?
The function. Or what
You-
component Y is.
So Y is a salt bridge, and we have 2 functions. So I'm passing. In which directions will electrons flow?
And
We use the table here.
yeah.
Which one is the anode?
And
Okay, let me hear from those at home. Which one is the anode? Somebody quickly talk. If you are not sure, let us help you. Which one is the anode? Linda says Ni.
I would like to disagree with them.
Mohammed says Mn. So if we're having 2 answers, then we have a problem. So let's deal with the problem. Which table are we using? Let's use 4b. All right. Please make sure we're not using 4a. 4b. We have Mn and what? Ni. If we scroll, Mn comes first. So automatically, Ni is at the bottom. So Mn is the anode. Linda, are we good there? So this is my anode. Don't make a mistake of that one. So electrons would move that way. This is what you're going to hear or see on Monday. They will draw that electron. So know where it's coming from the anode to the cathode. Or let's talk about polarity. What type of cell is this? It's a galvanic. Anode is positive in the electrolytic ape. It means anode is negative here. So they can also do this, negative and positive. Okay.
Open
And when we talk about the ions, this is the cathode, right? What's going to happen to the ions? Our cations would come here, while the anions would come here. So those are ways of finding the anode and the cathode. Or they tell you, what's that? It has increased in mass. Okay, so electrons are moving from where? 8.2.3, please give me an answer. Positive 0.91 volts. Please put the positive for me. Do we agree with that? Is there anybody who did not get the 0.91? Let's help quickly. Yes, it is possible to get a negative. And the negative would have come because they can ask you that. It means the learner has switched this voltmeter. If you switch the voltmeter, you'll get a negative 0.91. Please talk to me. Are we all okay here? If we're okay, we want to move. We don't want to waste time. Is there anyone who needs help on how to calculate? And please don't write E-cat. We don't have a cat here. This is not a zoo. Please write the formula the way it is. E cell equals to E cathode minus E what? Anode. Already, that is why it's important to get which one is anode and cathode. This is your nickel, and this is your what? Manganese. And then you put your answer there. All right. Write the balanced equation for the net cell reaction taking place. Okay, let's quickly guide everyone on how to write that. Very, very important. Very, very important. Important 3 marks. So we are using Mn and what? Ni. Already, so we know this is what? 4b, right? Lovely. And I'm glad both of them actually fit into this thing. So what do we do here? Why do I keep drawing? Jacob Zuma, my beloved president. There we go. And there we go. And if you want to fulfill all righteousness, to remember. So which one will be my anode? Oxidation. It's the one on top, right? Oxidation and what? Reduction. So what's the oxidation one going to be? Mn, which is a solid, to give us what? Mn2 plus what? 2E. What about the reduction? Copy and paste, right? Ni2 plus. So what do? We look at the electrons. Since they are balanced electrons, we just write what's on the left to the left and what's on the right to the right. What we have? Mn, which is a solid, plus Ni2 plus, which is what? Aqueous there. What do we have? Mn2 plus, which is what? Aqueous, plus what? Ni. Please quickly, while we are here, quickly write cell notation for me. Cell notation. I know they didn't ask us. Please quickly write the cell notation. ABC. Simple as ABC. Anode, bridge, and cathode. So you write the reactants at the anode first, then you go to the bridge and write the reactants at the cathode. Are we done? Let's have you okay? All right. Cell notation, we start from the anode. What do we have? Mn solid, Mn2 plus. All right, I already see a problem there, right? Different faces. Then what? Salt bridge. What do we have? Ni2 plus, which is what? And then we have what? Ni solid. That's 3 marks. 1, 2, and 3.
So even if you write it wrong, you got the salt bridge there, you get the mark.
I'm not sure. I need to check. I've forgotten how we mark that. All right. The last question. I hope everybody's okay there. Please, no, here there's no room for error. Let's get it right. Okay. The concentration of Ni is now increased. What would happen to the reading? This is beautiful. This is our Electrolysis principle. Where is Ni? Ni is the cathode. And I remember telling you, look, if it increases, it means this value will also what? Increase. And if that increases, your E cell value will what? Increase. Done. If your cathode value increases, your EMF will what? Increase. Case closed. We are done there. Guys, are we okay here? You have, if they say give a reason, you have to use Electrolysis principle now. Yes. Okay, let's do it. Using Electrolysis principle. Why will that occur? Very good question. What is our reaction again? Mn solid, right?
Yeah.
Plus nickel what?
Oh, you have plus nickel 2 plus to give us Mn2 plus.
Nickel 2 plus to give us what?
Mn2 plus.
Mn2 plus.
Plus nickel solid.
All right. So it's a reversible what? Reaction. So check. If Ni concentration increases, the system automatically detects that there's more. So what will happen? It will want to use it up. And in using that up, what happens? The forward reaction will be favored because we are using it. So forward reaction is favored. Or we can start with equilibrium shift where? To the right. Equilibrium shifts to the right. The forward reaction, every time the forward reaction is favored, EMF increases. So since the forward reaction is favored, the EMF value does what? Increases. If we favor the reverse, EMF will decrease. So that's all I write for my explanation. Sir, will they deduct marks if you don't put the phases of the cell notation? No, they will not, Jessica, but I'd love you to do chemistry and just put it. They will not deduct. No, it's not complicated. You are telling them that you are not guessing. Okay, that one is done. Let's go for electrolytic cell quickly from the same paper. There was one you Sarah sent me, and I'm going to look for it. All right, look at this. Define electrolysis. 2 cell questions. Okay, guys, do you remember what electrolysis is? I told you how to remember. Electrolysis is a process.
A process whereby electrical energy
is converted to chemical energy, and we're done. From elect. Okay. The graph below, let's read. Ooh. The diagram below represents a simplified cell used for the electrolysis of compound concentrated chromium 3 chloride, CrCl3. Electrodes R and T are made of carbon. Okay, so we have the net. They're giving us the net reaction. The graph below, not drawn to scale, represents the changes in mass of electrode T. So what can you tell me? T is the cathode. Why? It's increasing in mass. So automatically, we know that this one is now what? The cathode. So every information I find, I just quickly put it there. Write down the half reaction that occurs at electrode T. Please give me an answer. 9.2.1. You have 10 seconds. And you can write it without the table. You don't need the table. It is the cathode. It's gaining mass. So we are forming a solid. Case closed. And it is, if it's forming a solid, that's reduction, which is gaining of electrons. So I'm done. Cr3 plus will gain what? 3 electrons to give me what? Cr solid. You see that, right? So just connect the whole thing. It's gaining mass. For me to gain mass, I must produce what? A solid. We're done. But you can use the table. All right, look at the next one. We've got 9 marks. Stoichiometry. A current of 2,5 amps passes through the cell for 10 hours. Let's write the information we have. What do we have? 9.2.2. Current is what? 2,5 A. What is time? 10 hours. Times what? How do we convert hours to seconds?
6.
Stop lying. Please, can you do 9.2.2 for me? I showed you how to do that. We are looking for total charge. Please, that one is very simple. We are looking for Q. Very simple, very straightforward. Where? Oh, yeah. Shame, poor child. Please calculate Q. It's 3 marks. Are we done with the first one? Are you done with the first one? What are we looking for? The table Q. What do we have? I. T. What's your formula? Do you have a formula page there? Yeah. What are you trying to remember? Negative 90. Do we agree with this?
Yeah.
Q equals to I delta T, right? What's your answer? 90? Wrong answer.
90,000 nano.
Stop lying. Columns.
Oh.
It's electrostatics, quantity of charge. All right. Calculate the value of X as shown on the graph. Let's go through together. Basically, X would be the new mass that is added. So we're talking about T. All right? And what do you notice about T? Guys, we're looking for mass. I want you to see how I'm going to do my stoichiometry. And this is where learners miss the stoichiometry part. The flow of the stoichiometry. Please don't rush. Quickly create a mind map. Oh, I shouldn't have done all of that. I need this. We want to find the mass created of chromium. But how do we get mass? Come, walk with me. Number of moles is what? Mass over molar mass. Okay, do I have the molar mass of chromium? Yes, periodic table. But what is missing? So I have this, but I don't have this guy. So my job is to calculate the number of moles of electrons. So how do I get that? What do we have? Remember what we said. We got Q. What was our Q? 90 what? In fact, this is exactly what I did. 90,000. We need to get the number of moles. But how do you get the number of moles? I cannot get the number of moles until I get the number of electrons. And how do I get my electrons? Number of electrons. We said what? Q equals to what? NQE. What is this? We got what? 90,000. Do I know N? No, right? What is this? 1,6 times 10 to the power negative what? 19. The negative will not really matter. Please give me an answer for number of electrons. N.
Five,
5,62 times 10 to the power of what? 23 electrons. It's fine. The negative just tell you we're losing. But then I need to convert this to number of moles. How? Number of moles is number of electrons over what? Avogadro's what? Constant. So this is the number of electrons. 5,62. Now, what is my Avogadro's constant? 6,02 times 10 to the power what? 23. This gives me the number of moles. What's your number of moles?
1125.
Are you sure?
Over 1125 over 120.
Okay, give me decimal. 9344 what? Moles of what? Electrons. It's exactly that stoichiometry that I told you they will ask you. Now I know my number of moles. Can I go to my ratio? Okay, let's move this up if we can keep it on the same page, keep everything on the same page. Now what do I know? Electrons and what? Chromium. How many moles? 3:1 from your balanced equation.
Oh, if you said
So what's the number of moles of electrons that I have? 0,9344. Can we find N? Find number of moles of chromium for me quickly.
0,3115.
3. You sure? Because I'm trusting your answer. Cross multiply and divide. Now I have my N. Beautiful. Number of moles is mass over what? Molar mass. Does somebody have the molar mass of chromium for me? 52. So what is the mass? Yes? No. The 2 has no effect. 16 comma what? 2 moles. Now that is what we gained. So what is T? Or X? Huh? Grams rather. Yes. So what is X therefore going to be? 16 comma 2 plus 2 comma 2. And that will be what? Yes. It means we gained 16.2. It was 2.2 before. Then we gained 16.2. So X is now what? 18.4 grams. Guys, that is your... Please know how to pull those formulas together. Know what each symbol means. Number, especially that those N. The N is my problem. Number of moles and number of electrons. So that's why that page that I gave you the formulas for each of those. Please let me know if the stoichiometry makes sense. Any question? Okay, so we are done with that. Let me just quickly look for, I want us to do one more. One moment, somebody sent me. One moment, I'm just looking for one question. Please, practice, let's practice, let's practice. Oh no, now I can't download. Let me ask. Hi, Sarah. Okay, let's just randomly pick. I want to deal with national papers though. I don't want to deal with these prelim papers. I figure our prelim papers are not helping me. Maths taught me something. I promise you. That maths paper had nothing to do with prelims at all. At all. It had nothing to do with those prelim papers. Oh, by the way, guys, I think it would be nice to answer 2 multiple choice questions. You agree with me, right? Okay, let's see. Please give me an answer to 1.9. Okay, are we done? Use the table. The movement of ions, not electrons. So all I need to do is to identify my anode and cathode.
Zinc is your anode.
You sure? Do we confirm that zinc is the anode, everybody? Are we confirming? Because I don't want to go to the table. All right. So zinc is my anode. So what are we expecting to come to the anode? Anions. And what are we expecting here? And we know the cations are what? Positively charged. And the anions are, so we should have what? Cl minus here, and we have what? Potassium ion. Okay. Type of ions. Okay, let's see. Where is Cl moving from? Okay, definitely look. This is out, this is out. All right. We know that Cl must go to X. Don't let all this Y to X confuse you. 2 is what is matter. Well, the destination is what matters. So where should Cl go to? Cl should go to what? The wait. What are they saying? I want to something. Which one of the following describes? Oh, so we look at Cl and we tell where it's going to, right? So we know Cl is moving to what? X. So option is what? A. Make sense? Ions. Anions will go to the anode and cations will go to the cathode. Is it homonyms or what would we call them? English. Things that sound alike. Not onomatopoeia. I don't even remember what that thing means.
Bang.
Huh?
The sounds.
Sound is what? Homo.
No. Onomatopoeia is your sounds.
Okay. If I teach you now, you'd fail English. Please answer this one. And we answered this today. We answered all of this today. Okay, can I get answers? A, B, C, D. Those of you at home, I need answers. The tabs, answer? C. Yes, what's your answer? B. What's your answer? Are you sure? Can you explain? I think we answered this. Impure copper should be the anode. And the pure one should be the cathode. And if it's the cathode, the mass what? So basically, to remember, you're saying you want to transfer from here to here. You want to transfer what is pure from there to there. So the mass of X should what? Increase. So these are all content-based questions. Okay, let's quickly do one more. Please remember, you can, while studying, send me your questions. I'll try to respond. Oh, come. I need 16 marks here, guys. Quickly.
12.
12. What do you mean? I want my full 16. I am not negotiating here. I need my 16. And I'll only give you 10 minutes. Do it judiciously, meticulously. Use a formula page. Write, please don't write shortcut answers for me. Write full, detailed answers. Good luck. Okay, can I mark this quickly? Let's see if we can do this until 6:30. I needed to do some chemical equilibrium too. Just maybe 2 questions to remind ourselves. All right, let's see. The table below shows cell A and B used to assemble. Okay, so we have A and B. Now, you know the first thing I'll do here is, which one is my anode? Huh? Cu. Are you sure? And we're using Cu2 plus, right? Oh, nice one there, I see. We have to answer that one too. Quickly, 7B. Guys, just use your 7B. Please mind the copper you are using. This time around, I'm using the 0.34. And where is silver? I think silver is down, right? Ag is 0.80. And copper, I'm using copper 2 plus and copper. How do I know that I'm using copper 2 plus and copper? Look, they gave it. Just observe. Copper 2 plus and copper. So it's the first one on the table. So that should be my what? Anode, right? And this should be my energy conversion. Come, quickly. Chemical energy to electrical energy. Done. Calculate the mass of silver nitrate used to prepare. That's grade 10. To prepare what? 150 cubic centimeter of electrolyte. Shh, do you notice they didn't give you the concentration? But we have it. It's a standard. What is the concentration? 1 mole per dm cube. So my concentration is 1. What else do I know? Volume is what? 0.15. Because we divide by 1,000. What are we looking for? Mass. Is there a formula?
Yes.
What's the formula? C equals to? Well, we have volume. Okay. N over V, right? So mass over molar mass and volume. I can combine it. There's a formula like that that combines. Okay, what's my C? 1. We're looking for mass. What is the molar mass of silver nitrate? Did you guys get it?
Yeah. 108.
1?
14 plus 16 times 3.
Final answer? 170. 170? Agreed? 170. And what's our volume? 0.15. What's your mass? Quickly. 25,5 grams. Let me see. Talk to me, people. Guys, I'm not getting responses. Okay. I think we did 8.3 today. What is a reducing agent?
The substance that loses electrons.
You see that loses? Reducing will be oxidized. Oxidation is lost. Yes. A substance that loses what? Electron. We're done. Write down the name of the formula of the reducing agent. Which one is oxidized? We are looking for what is oxidized. And that one would occur where? At the anode. So what is oxidized? Is it copper or copper 2 plus? It's copper. Because copper is 0. Copper 2 plus is positive 2. Beautiful. Copper. Because oxidation is an increase in oxidation number. Oh, balanced equation for the reaction that takes place. Let's do that together quickly. Copper is on top, right? So what do we have? We have copper 2 plus. I'm just writing what we have as it is on the table to guide someone. I'm sure that's what we have on the table, right? Yeah. And then we're saying what? So for the oxidation, what do we have? Copper. Do you see where that copper came again? Plus 2E. And then we have what? Ag plus E to give us what? There's a problem. So what do we do? Multiply this by 2. Can we write our final answer quickly? What do we have? Cu solid plus 2 silver what? Ions, which are aqueous. Then what do we have? Cu2 plus, which is what? plus 2, and that is a solid. When you write your cell notation, please don't write the 2's. Don't write the 2's. The 2's have nothing to do. What is your 8.5? 0,
0.46.
wrong answer. Positive 0.46 what? Volts. Okay. Yes, please. How will the EMF of the cell be affected if the concentration of copper ions? Now, this one is the anode is now what? Increasing. Oh, beautiful. What is your E cell? We said it's what? E cathode minus E what? Anode. Which one is increasing? You are subtracting something big for what is constant. So what's your answer? Explain using Le Chatelier's principle. Increase in what? Explain. Let's explain using Le Chatelier's principle. So what's our equation? We are saying this one is increasing, right? So if it increases, the system will want to use it. So the reverse is favored. So what do we say? An increase in the concentration of Cu2 plus favors what? The reverse reaction. Equilibrium shifts to the what? To the left. Equilibrium shifts to the left. So what happens? The EMF of the cell will do what? Decrease. So please take note. If the reverse is favored, decreases. If the forward is favored, increases. Okay, beautiful. Guys, are we on the same page so far? I really need this to be in. I need my 25 marks to be in. There's only one thing, after doing this, there's only one more I need to look for. I need to look for the one with, or two more. I need to look for the one with a gas. And I need to look for the one with a mixture of ions. And then we're done. Please quickly answer this for me. 10 marks. 10 minutes. Come quickly. There's a stoichiometry here. All the rest of these questions you can answer in 3 minutes. And we spend time on the stoichio. Okay, guys, are we done quickly? Did we finish? Especially the stoichiometry. I'm only interested in the stoichiometry part. Quickly, what do we know? Electrolyte, boom, done. Ionic solution that conducts electricity through the movement of ions. Finished. It's pure chromium. Okay, we did this as well. We are electroplating the ring. So whatever we are electroplating should be at the cathode. So my ring should be what? The cathode. And the pure one should be the anode. Is the pure chromium the anode? We are done, right? Pure should be what? The anode. Give a reason. Oxidation occurs there. Write down the half reaction that takes place at the ring. At the ring, a solid must be formed. So it's chromium 3. So what do we have? Chromium 3 plus 3 electrons to give us what? Chromium, which is a solid. Calculate the total charge transferred when the mass of pure chromium changes by 2. First thing is, what is the formula for Q? Q equals to what? NQE. You start from there. This I have. Do I have the number of electrons? No. How do I get the number of electrons? Number of electrons, I use this formula, right?
Yeah.
Where this one is now number of what? Moles. And Avogadro. So I need to get N. Let's see. Do you think I can get that? What is missing? Okay, so let's write the equation quickly. What do we have? Cr3 plus what? 3E to give us what? Cr. We need to get the number of moles. What do we do? We do have the mass of that. So can we convert? Number of moles is equal to what? Mass over molar mass. 2 over 52. What's your answer? 1 over 26. Give me 4 decimals. 0.385 moles. But then I know E to CR 3 is to 1. So 0.0385 N. So what is the number of moles of electrons? 1154. Now, number of moles is that over Avogadro's what? Constant. 0.1154 N over what? 6,02 times 10 to the power 23. What's your answer? 6,9531. 20? Good. That's the number of electrons transferred. I am now back at Q. So write what you are looking for. Then case closed. So what is the number of electrons now? 6, what? 9531 multiplied by what? 1,6 times 10 to the power of negative what? 19. What's your answer? 11124,96.
24,96.
Columns. Guys, please, I hope we are all okay. That is how we do our stoichiometry. Please, that's how we do our stoichiometry. You know what I'll do? Because I want us to do the others. I'll look for those particular questions that I'm talking about and just do a short, you know, those little 3 minutes solutions for us, and we are good. All right. Guys, what should I know about chemical equilibrium? What are the definitions? Let's make a list quickly of our definitions. What should I know? Number 1, define reversible reaction. Define a closed system. No, this one is not external forces, please. A system where there's no exchange of material and heat with the environment. Okay. What else do we need to define? Dynamic or chemical equilibrium. What is this? It's a state where the rate of the forward reaction. All right. Number 4, I remember something now when it's gone. Homogeneous and heterogeneous equilibrium. Anybody remember what Homo talks about? Say all the products and reactants are in the same what? Phase. Gases, 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 and on like that. Number 5, Le Chatelier's principle. Please go and learn that. Number 6, application. That is how your concentration, pressure, and temperature affect what? Equilibrium. I think we did concentration earlier on. So let's talk about how pressure affects. Let's quickly talk about pressure. And then 7, we talk about your Kc. Quickly, let's talk about how pressure affects. Pressure. Talk to me. Increase in pressure. And how would they argue that pressure is increased? They tell you that, no, they tell you that volume is decreased. Favors the side, favors the reaction that produces fewer number of what? Moles. And that's not complete. Fewer number of moles of gases. What about temperature? The increase in temperature does what? Favors the endothermic. Can I say and vice versa? And vice versa. What about Kc? Let's talk about Kc. All right. Kc. Okay, let me do a little write-up on Kc. Guys, are we okay so far? Some little things to remember there, here and there. Okay. Let's talk about Kc. What do we say? Constant of product over that of what? Reactants. If Kc is greater than 1, what does it mean? Sorry? Here, we are talking about what? Forward reaction is favored. And that means we have more what? Products. Then the arrow is going that way. What about less than 1? The reverse reaction. You can see where the arrow goes. Reverse reaction is favored. What else can we talk about? The Kc of the forward is 1 over Kc of the reverse. Okay, what else can we talk about? Only temperature affects what? Kc. Let's do a 4 marks question quickly. 4 marks. Question. Temperature was increased. Temperature was decreased. And the Kc value increased. Is the forward exo or endo? Please answer for me. 4 marks. Let's see if you remember. Three minutes, 30 seconds. Okay, guys, you would mark yourselves, but here is the process. First, let's look at the first line. Temperature was decreased. What do we know? Increase in temperature favors the endo. So a decrease in temperature favors the exo. So we start by writing that. A decrease in temperature favors the exothermic reaction. So always deal with what is favored. Number 2, we go to the next point. Kc value increased. Look, come back to your Kc. For this one to increase, more product has been formed. So I'll say Kc value increased implies that what? More products are formed. And if more products are formed, which reaction is favored? Forward. Forward reaction is favored. Oh, then I can make my conclusion. We said exothermic is favored. Forward is favored. So favor and favor. It means exo is forward. So always talk about what is favored. It makes life easy. Forward is exothermic. And guys, you don't want to write stories. 1, 2, 3, and 4. Keep what is favored as your guide. Are we okay? Everybody okay? Let's see those of us at home. Are we good? Are we awesome? Beautiful. Okay, let's tackle a question of, yes, talk to me. Yes, talk to moi. Linda, you're raising your hand. Please talk to me quickly. Marks. Linda, just follow the statement that I wrote. Deal with what is favored. You must know the statement of fact. Temperature is decreased. A decrease in temperature favors exo. If you don't know the effect of those things, that's when you suffer. We said increase in temperature favors the end. You must never forget that. But this time around, we are decreasing. So it favors the exo. Then you go to the second. Kc value has increased. Use your formula. For this one to increase, which one must increase? This guy. If this one decreases, it means this one must increase. You must always talk about the one that increases. So Kc increased, more products are formed. And that is your forward reaction being favored. Then you combine your first and third statement. We are saying exo is favored, forward is favored. So if exo is favored, replace the word favored with exo. Simultaneous equation. Forward reaction is favored. But what is favored? Exo. Linda, are we okay there? Please, I need you to get those 4 marks. Very, very important. If you can just do it this way, boom, 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 we're done. Guys, there we go. 12 marks. I need that table answered. Come quickly. Let's see what you can remember. 10 marks. You don't need more than 10 minutes. All right, guys, let's quickly answer this together. Consider the balanced equation from a hypothetical reaction that takes place in a sealed, closed 2dm cube. If it's not closed, we cannot have equilibrium. Define the term equilibrium. You see all the definitions are there, right? State of what? Now, there are two definitions of chemical equilibrium. I don't know if we can remind ourselves. Please, let's remind ourselves. Net force. Chemical.
Wait, this is the product is equal to the reaction.
It's a state where one, the rate. Please don't say forward. It must be rate. Rate of forward reaction equals the rate of the reverse. What's the second one? It's a state where the concentration of products and reactants are what? Constant. That is where we talk about, on the table, we talk about equilibrium concentration. Please note those two definitions. All right, what do we know? The amount of each substance in the equilibrium mixture at 300 Kelvin is shown in the table below. The temperature is now increased to what? 350 Kelvin. When a new equilibrium is established, it is found that 1,2 moles of P is present in the container. Is the heat of reaction positive? Is it an exothermic or an endothermic? Let's see. Let's try to determine. And do you notice that actually my 4 marks there? The 4 marks we just did, 1 and 3. So let's look at it quickly. What are the things that I would look at? Amount of moles at what? Equilibrium. Now, do you notice this one is 0,8, which is a reactant? Now, they told us it increased to what? 1,2. What can you tell me? The reverse reaction has been favored. So what had happened to Kc? So remember, Kc is that over that. So this has gone up. What happens to Kc? Kc has decreased. So first thing that I would say, I'll say Kc what? Decreases. It means the reverse is favored. What did we do to temperature? We increased temperature. And increase in temperature favors the endothermic. Increase in temperature favors the endo. Look at, we have used favored twice. Which reaction was favored? The reverse. Which reaction is favored? Endo. So what are we saying? The endo is reverse, which means the forward is exothermic. And if the forward is exothermic, what is delta H? Do you notice I answered all of those before I came back here? This is where negative marking occurs. If you choose positive, forget about the 4. Because you are only telling us why you are wrong. Amplifying why you are that. Guys, I'm wrong because of this. So please, answer 6.2.2, then go back.
Giving the right answer to why you were wrong.
Yes. So
It deserves a mark.
no. It means you are completely wrong. So we just answered those 4 marks. Now, I hope that makes sense, everybody. Linda, do you see again how we used it? Calculate the equilibrium constant at 380. Okay. 8 marks. Now, do you notice we have equilibrium already? Now, but they said when a new equilibrium is established, it means the old equilibrium becomes my initial. Okay. So what do? We eat rice. Please don't be lazy. I know if I check your book now, you wrote rice. I'm very sure. That one, I can put my life on it. That if you wrote it in full, I must be assassinated. Can I check? I knew it, that it's rice. Okay, what do we have? Ratio, initial what? Number of moles. What do we have? The change in the number of moles. Then what do we have? Equilibrium, number of moles, and equilibrium what? Concentration. And V equals to 2 dm^3. All right, so this is how I rule my lines. Beautiful. Okay, what do we have? P, Q, and PQ. 2 and 2. P, Q, PQ. Ratio 2, 1, and 2. Now, we're not starting from 0. What are we starting from? You see, amount in moles. Please make sure you pay attention to that information. 0,8, 0,8, and 3,2. Then they told us at equilibrium what happened. P now becomes what? 1,2. Instantly, you would see that that is a plus. And these two are on the same side. So both of them should be what? Pluses. I cannot plus 1 and subtract 1. Now, but on the other side, negative. Now we begin with the maths. 0.8 plus something is 1,2. What's your answer there? I know that you're going to say something like that. 0,4. The question is, do I know how to fill those? Look, a quick one that you must quickly see. What is the ratio here? What's the ratio here? Copy and paste it. It's 2 to 2. Here, if you can see that it's 2 to 1. Do you notice 1 is half of 2? So this should also be what? Or what do? We talk about eating rice, since Shami wants rice, and chicken. R and C. What do? Cross multiply. No. Rice to chicken, rice and chicken. So what do I have? 2A equals to 0,4. What is A? 0, what is A? You guys are tempting me. 0,2. Okay, 20 over 100. 20%. Because you could see a question like 20%. You just change it. Now, can we do the maths? What is 0,8 plus 0,2? That's 1. Leave me alone. What is 3,2 minus 0,4? 2,8. Can I get my concentration? Number of moles divided by volume. Do we have our volume? 2. So what do we have here? 1,2 divided by 2 should give me what? 1 divided by 2 should give me what? 0,5. And 2,8 divided by 2 should give me what? This is known as my equilibrium what? Now this would not change. And this is where we talk about chemical what? Equilibrium at this point. What is our Kc? Please don't say this one is now product. No, we still maintain. P, Q to the power of what? 2 over what? P to the power of 2 and Q to the power of what? 1. What is PQ? 1,4 squared. What is P? 0,6. Also what? Squared. And 0,5. What's your answer? 10? All right, let me pause for digestion Please ask me questions here. Talk to me. Guys, give me thumbs up, thumbs down. Are we okay? All right. Please, it's very important. Send me, let's do as many as possible, and give me challenges. Huh?
You're not coming to work on Monday.
Why not?
Aren't you going on holiday?
No. Holly what?
So taking a class.
Holly what? Okay, where are we now? 6 point. Let's answer the last 4 marks. Come, let's answer. Let me give you time to just try to answer those 4 marks for me. Quickly, let's see. Answer. All right, guys, let's answer this question. How will the equilibrium calculated in question 6.2.3 be affected when the volume is decreased? Remember, we said it's only Kc that affects what? Is that fine? Only only temperature affects Kc. So what's going to happen to this one? It remains what? The same. What's going to be your reason? Just mention that only temperature affects what? Kc. 6.3. More Q2 is now added to the reaction mixture at constant temperature. How will this following affect all of this? Okay, let's go to the reaction. If I add more Q, what's going to happen? The system would observe that there's extra, so it will use it up. In using it up, which reaction is favored? The forward. It means there will be more products and less what? Reactants. Okay, I hope that makes sense. So what are we looking at? PQ is a product, right? What will happen to the yield? Increase. What about the number of moles of PG? It will decrease. I hope it makes sense, because it's P plus Q to give us what? Is it Q2? I think it was Q2. Yeah, because I'm saying something is not balanced there. Please, let's correct this one. It's Q2. Quickly, guys, just to make sure we understand this. If I increase this, the system will now say I have extra. So what does it want to do? Use it up quickly. In using it up, more products are then what? Formed. So forward reaction is favored. More, and these two will what? Decrease. Guys, I hope the lesson made sense to you. Any question you would like to ask? I'm going to quickly resend all the chemistries we've done the last push, because I know there was one whole session where we did only organic. Please I know you're tired, get back home, rest. Tomorrow morning, watch that organic, then answer question. Today we did what? Equilibrium and rate. You are here. Answer questions. I don't know if we did acid. We also did the rate in one of the videos, one of the lessons. Yes. Acid and base, did we? Okay, that means the only revision I'm owing you is acid and base. However, we have revisions on that. Tackle question. First thing on acid and base, definitions. Please. So many people focus on 10 marks question for nothing, and they forget what is an acid, what's a base, strong acid, strong base. I think in those videos I even explained how you get the pH of the final solution. So please, before you answer papers, get content, then answer. As you are answering, like we did for physics, send the challenges you have. As I have time, I'll respond. On Sunday when we meet, we're just touching basic. Sunday is just to boost your confidence, not anything new. But on Sunday, we can do more acid and base, only acid and base. 3, 4, 5 questions, just to make sure that we are okay. Or any question I couldn't send answers to. Are we okay? Have a beautiful evening, everybody. A good night rest will be nice with this beautiful weather. Bye-bye. Bye.